our triangles. So we're looking at similar triangles here. And remember we said that similar shapes, they have the same shape, they have the same angles, the angles are the same. The only thing that's different about them is their size, and their sizes are proportional. So again, similar, if I put it on a copy machine and made it bigger or smaller, the angles and the shapes are the same, but the size is not, but the sizes are proportional. So I can talk about measuring the sides and having them be proportional. Let's look at the angles of similar triangles. When two angles in one triangle are congruent, they are equal, to two angles in another triangle, the third angles are also congruent and the triangles are similar. So if I want to take a look at two triangles and decide if they're similar or not, if I don't have side measures, I can look at their angles. And if I can find that two of their angles are the same, are congruent, the third angles are automatically congruent to each other. So for instance, here I have a 95 and a 95, and a 65 and a 65. Now if I didn't know about the 20, I have enough information there to know that these two triangles are similar in shape. They are proportional in shape, because these three have to add up to 180. So if I do 180, and then I subtract my 65 and my 95, I have to get 20. And if I do 180 and subtract 65 and 95, I have to get 20. So even if I don't know about that 20, and I only know two pairs that are congruent to each other, I know they are similar. Remember we use this little wavy line here to talk about similar? So triangle ABC is similar to triangle DEF. All right, so let's use that to decide if some triangles are similar or not. So here I have two triangles. They've given us some of the angles here. So I have 58 degrees, I have 43 degrees and X in my first triangle. And I have 43 degrees, 59 degrees, and Y in my second triangle. So let's see if we can figure out what the measure of X is here, because I know that I've got one pair of matching angles. They both have the 43. So it'd be nice if I had two 58s here, or I had two 59s here. That would work. I know these two are not the same, because they're not the same measure. So let's try to find X. X plus 43 plus 58 equals 180, because I know in a triangle they have a sum of 180. Combine like terms, X plus 101 equals 180, subtract 101, I get X equals 79. So this angle here is a 79 degree measure. So I've got 43 and 43, those match up. I have 58 and I don't know what that is, but I've got a 79 here, and the 79 doesn't match up with my 59. And you're like, well, maybe the 79 matches up with the Y. But if the 79 matched up with the Y, the 58 would have to match up with the 59. But it doesn't. So I don't have two pairs. Now I could keep going and find my Y. Y plus 59 plus 43 equals 180. And when I do the math on that, I get Y equals 78, which means that this angle here is 78, and it's not congruent to an angle in that first triangle. So that tells me that these are not similar. They do not have two because they do not have two congruent angles. So here's my reasoning for that. Let's take a look at another set. Now this set here has those little squares in the corners. So I know that these two measures are 90 degrees. So I know I already have one pair of congruent angles. Check. Now I'm hoping that I end up with another pair over here, but I don't have a pair yet. So I've got, let's work with my X. We could have worked with the Y just as easily. 90 plus 43 plus X equals 180. When I combine like terms, I get 133, and when I solve for X, I get 47. So this last guy here is 47 degrees, and there we go. We have a second pair of matching angles. I don't need to do any more work than that, because I know if I do 90 plus 47 and subtract that from 180, it's going to end up being 43, because that's just how triangles work with 180. So they are similar because I have two congruent angles. Okay, so let's take this idea here, that as long as I have two angles that are the same, the two triangles are similar and therefore proportional, and use it in an application, a real-world application. So you plan to cross a river and want to know how far it is to the other side. You take measurements on your side of the river and make the drawing that is shown. So here I have this drawing. We were able to measure on this side of the river here. And they created two triangles here. These are both right triangles, if you notice that. And we have measurements here on this side of the river. We're trying to figure out how far is it to get across the river over here. All right, so let's explain why triangle ABC and triangle DEC are similar to each other. Because if they're similar, then I can use a proportion to figure out this missing side, which would be super helpful, because it's going to be hard to measure the distance across that if I'm actually standing next to the river. So we have triangle ABC here, and we have triangle DEC here. Remember, careful with our letters, the arrangement. Angle A and angle D correspond to each other. Angle B and angle E correspond to each other, and angle C and angle C correspond to each other. That makes sense. All right, triangle ABC and triangle DEC have congruent angles, so they are similar. What congruent angles do we have? So we have B and E, so this is a right angle, so that's 90 degrees. And this is a right angle, so that's 90 degrees. So I have two angles that I know are congruent. I've got one pair that works. This other angles over here I don't really know anything about. However, if I look at angle, what I call ACB and ECD, I can't call it angle C because I'm not sure which. I've really got four angles that I could call angle C. So I'm going to talk about angle ACB, which is here, and angle ECD, which is here. And if you flash back to the beginning of the chapter, these are vertical angles, and we know that vertical angles are congruent. So I don't know the measure of those two angles, but I do know that whatever the measure is, it's equal to each other. They are the same as each other, and our rule here says that as long as I have two angles that are equal to each other in my triangles, that they are similar. So I've got a 90 degree, I've got one pair, and I've got this two, I've got another pair. The third pair has to be congruent also, so they are similar. Because they're similar, they are proportional. Remember, the shapes are the same, the angles are the same, the sides are not the same. They are proportional. I can write a proportion to figure out the distance across the river here, which is, I'm considering my x. So what I'm going to do is I'm going to set up a proportional, because my similar triangles are proportional. Now, I've taken one of my triangles and put the two sides in a ratio, like this, but then I always get confused about what should match up with which sides here. So I'm going to figure out which ones match up with each other. So 40 here is in between B and C, which is my right angle and my vertical angle. So I'm going to find the side that's between my right angle and my vertical angle on the other triangle. My right angle and my vertical angle. So that must be 30. So 30 and 40 are corresponding to each other. So when I go to put my rest of my ratio here, my 30 and my 40 should be kind of matched up with each other. And then my 50 is between my right angle and that unknown angle. And x is between the right angle and the unknown angle. So these two kind of match up. So those I'm going to put in my denominator. So there's my proportion. Now I'm going to set up my equation from that using cross products. 40 times x equals 30 times 50. And then I solve from there. 30 times 50 is 1500. That equals 40x divided by 40. I get 37.5. So the distance across this river is 37.5 feet, which makes sense. This measurement here is smaller, so I'm expecting my ED to be a little bit smaller than AB, which it is. So we can use that similar triangles here to actually figure out some missing measures of an actual real-world situation.